All right. Hello, I'm Brent Clausner. I'm going to talk a little bit here about enhancing validation through attestations. I'm not sure if everyone's familiar with attestations or not. I'll get into it a little bit. It's part of the legal stuff I have to go through. I'll tell you a little bit about myself. I'll go into the attestations overview. It's going to be very difficult to see. I like dark mode, and apparently it's. Are we able to turn the light out for like up here, maybe? Is that a little bit better? I know like the dark on dark is like for like this, it can be difficult. Uh, I'll read it whenever it comes time to. So I'll talk a little bit about the why and how of attestations, some of the current tooling that's kind of out there already in the field, in industry. More specifically, a lot of the terminology that I'm going to be using, because it's kind of specific to the type of tooling that I'm working with. I talk a lot in here about in-toto, and so I'll go through the normal usage that is proposed by in-toto, and I'm going to go through what I was writing about in the paper about what I proposed, and I have some actual automation and stuff I can show, so you can see it actually in action. So my professional background, I've done a little bit of. I came from like the train industry, like the railroad industry. I've done some work there with software, dealing with some kind of artificial intelligence before AI was like getting to be a bigger boom. Then I transitioned into hardware, like network storage devices. So dealing with all sorts of problems in that area. Transitioned to another company, and then now I'm working at Carnegie Mellon University. I'm with the Software Engineering Institute. So I went from everywhere from data tech, QA engineer, software engineer, now the DevSecOps engineer. Some of my interests professionally, I like technology. So I like to dabble in whatever kind of technology I can get my hands on, like 3D printer, as long as it's, financially feasible. Personally, I do enjoy video games a lot, so that's how I spend most of my free time. That and hanging out with my family. Okay, attestations. So many people here familiar with software attestations. Anyone? No? Okay. So it's defined as an authenticated statement. It's metadata about software artifact or a collection of software artifacts. This is based upon the slsa.dev. That's the supply chain level of software artifacts. So like, why would you want to do something like using some kind of attestation for whatever given software you have? This can help to prevent things like the SolarWinds attack. So there were deficiencies in the supply chain, which allowed bad actors to get in to do things that caused leaks. So I have here like a how, like what are some of the normal things that people do whenever it comes to supply chain? So you can think of like the software supply chain as third-party libraries that you may be downloading and integrating into your product, or it can even be software tools that you're using. A lot of those you end up getting from a vendor or online website. You could do best practices right now would be to at least do a normal checksum validation to make sure that you're getting what the vendor intended you to get. So that way you're not getting a man-in-the-middle attack. So attestations also provide traceability into who did what and with what objects, and making sure that everything matches up. I'll show an example of it so you can get a little bit better of an idea into what all is included in this. And it does have verify commands that you can use to basically verify the build. So it is what was produced. Okay, so what is an attestation? It consists of mainly these things here: a statement, which contains a subject and predicate, and a signature. So this might be that's a little bit hard to see, but I have a better example here. So at least I have the popping white on the side. So this is an attestation that I produced with in-toto. So you can see the signatures up top. I have it kind of with ellipses so I can keep everything kind of formatted. But the statement would be the cargo.toml. So like down here, you can see materials, cargo.toml, and it has a checksum of SHA-256, which is included with that. So that's what's captured at the time that this was produced. The predicate is that checksum, and the signatures I had mentioned previously. So there's a little bit more additional information, and there's a lot of additional things with in-toto that I will be getting into. So some of the current tools here, I'm talking a lot about, you hear in-toto. I'm saying that a lot because that's the main tool that I've used. It does allow generation and verification of attestations. So you can use this. It's an open source tool, in-toto.io. That's where you can find it. I'm not sure what current version they're on, but they're changing things frequently. I'm on version 3.0, and I'll show you that in a bit. So another tool, Witness, it's implementing in-toto's ITE 5, 6, and 7. The ITE is the in-toto enhancement. It's like, if you're familiar with Jira, it's basically a key to indicate which requirement it would be. So 5 is to disassociate signature envelopes. So you can think of this as changing it from the way that in-toto had specified it. So it's allowing consumers to do that. 6 is to enable contextual attestations. So that's allowing changes to it with backward compatibility. And ITE 7 to allow you to sign and verify with X509. So I know they have a lot of additional algorithms that you may want to use or to implement. Another one here I have listed is binary authorization. That is an attestation one, but it's more for containers for Kubernetes. But it's not exactly the same as what I'm the application that I typically deal with. So the terminology that I'm going to be going into mostly is going to be talking about layouts. Layouts are a collection of steps, and it allows you to do things like specify what materials or products are there, and lets you do inspections. So the step basically is the command that you want to run, and whenever you do that, you have to specify the materials. That is, the materials are the files that are expected to be there. So whenever you run this, it's going to actually capture that with its own checksum of those files whenever that runs. Products, those are files that can be created, deleted, modified as part of executing that command. Inspection is kind of outside of it, so you can use it to say like, oh, do something with these objects as part of the run. So currently, right now, there's another thing that I didn't have time to put onto the slide, but it's called byproducts, and I'll show those in detail into like why you may want to be more careful with just like doing what in-toto may say to produce the attestation and hand it off to a consumer. So I'll show an example of that then. Okay, so how do they propose to use it? It's proposed to use a single layout. Basically, it's just specifying how to build your product and what should be specified or what's going to be there. And basically, you're publishing the layout, public keys, your attestations, and the actual binary executables for what's intended. The layouts are generally generated by Python in JSON format, and they do have expiration dates as well. Okay, so here's a simple layout that I had produced to do, I think I have like 1 or 2 steps in here. I think I truncated one of them. So if you're familiar with Rust, I don't know if anyone's familiar with Rust or not. Cargo is one of the tools that's used with it. That's why I had in there cargo.toml. But like, so the first step in this JSON list, I named it building. So you can see that I'm specifying within the layout specific files that are meant to exist, and saying things like disallow or allow. There's also things in products where you can say created or to match with additional steps. These things all have different implications. They can accept wildcards. So like the first expected material in under building is allow source/star. Typically with Rust, they look for a source directory to do this. I'm thinking of it as if I had a product that a lot of people were contributing to, the files can change, files are going to be added and removed. So I just wanted to wildcard that. Sometimes whenever you're building, you have object files that are being created. They may have different names to them or just being generated with timestamps. So you can't really determine what that's going to be from like a static file like this. So I just found it a little bit easier to do that. And it's nice that they let you do that. So yeah, they have a couple different commands. So allow is saying that the file or file condition is allowed to be there at a given time. So for materials, so we're like I said before, materials are allowed to exist prior to running the command. If you have it with the disallow star at the end, or if you always have that, you can find out pretty quickly what you didn't account for. It lets you find the files that didn't exist. So some of the things that I have in here I added were link and pub. So that's how I was naming the attestations. They're generated with a .link extension. Pub is what I was using for my public keys, because the public keys need to be shared, because that's also part of the what I was showing with the signatures. Let's see here. The expected command, you can see I have down here, that's where I was talking about cargo build. It's in the, I believe it's the, what do they call it, argument style. So it's like, it's removing the spaces. You're not giving a string of cargo space build. It's cargo and build to allow the system to determine whether or not the command is what was expected to be done in your layout that was used. I'm not sure exactly what thresholds for, but the pub keys, this is saying who is allowed to execute it. So you can say, you know, say your build system, I typically, you'll see in my example, I call it GitLab, because I typically use GitLab a lot with my pipelines. But they're the ones that can run it. You also have up top, outside of the steps, the key owner. So you can have it separated to say who is actually in charge of this layout. They'd be the ones in charge of generating it. You can also, I believe, put in an expiration date in here too. I think otherwise it defaults to like 30 days. I'll generate the layouts, and I can't show you the expiration because they changed it since it was more human readable. But I'll get into that a little bit. And then you can see like the second step that I have there is just packaging up the materials to produce it. So you can see what's different between the two steps is I'm matching the products and materials from building on both ends of the expected materials, because you can share that between steps. And yeah, I don't have anything in inspect, but that's okay. All right. So typically, what you'd have for proposed usage, and what I'm suggesting here is you could have multiple layouts. The first one being a build layout, similarly to what I showed. You'd want to use your static code analysis though. In the middle, in between doing build, so you do your build, you do your static code analysis. You're going to do some lint checks or whatever else you may want to do. And then package it up. So it could be including to, like, say, pushing to an artifactory, if you're familiar with that. That would be the step one. So is having that layout. So it's like multiple steps. So anyway, multiple layouts. So you could have a QA team or whoever is responsible for doing any kind of validation of the your software. What the layout would do, it would be expected to do a verification of the first layout. So what that's going to do is it's intended to say that everyone is testing on the same build. So it's going to attest to it. And this is actually creating a chain to the end consumer. So, but we're in the middle part here. So verifying that it's, like I said, yeah, ensuring the testing. Then you can do your testing. You could add into the second layout if you have automation to have it do its. It's basically the in-toto command. It wraps around it to generate the attestations. Like I said, I'll show that in a bit. And then after all that, you have a release-based layout. What this is going to do is basically ensure the verification of all the multiple layouts in the middle. So it's not doing the build layout because it's already verified within all the teams. And this is going to isolate some of the directories and output. So byproducts of what's in there, you wouldn't potentially leak things like, say if you're using a static code analysis like PyLint or something, and it has white space detection, that can be outputted in. Maybe your organization has coding standards that they're like, well, we don't really care about that. Generally, you'd have it in your PyLint RC, but if it is being produced and it's okay, that still would be included into the byproducts. So this will prevent that from doing it because that would be verified at this stage and it's not going to be released after here. Okay. So here I'm going into one of the layouts that I'm suggesting. I have it saying to do something very simple. Anyone who's familiar with a command line terminal, you've probably used the echo command at one point or another. I'm just having it saying echo pass. That's just to indicate that as a team lead, like whoever this owner would be issuing that command wrapped in the in-toto run to generate an attestation that's saying that this had passed. And yeah, doing things here with the verification of using in-toto layout here, or using the in-toto verify of the build layout. This is the actual command that's going to be run, and we'll see how it works. Right now, whenever you run the in-toto verify, if you have a command line failure, so if it's included in a pipeline, they do not they don't fail to verify if the command returns a 1. So if you're familiar with return codes on commands, that's a lot of how CI/CD pipelines can determine whether or not a thing passes or fails. I could show that. I don't know if I have that in my lint check or not included, but anyway. So yeah, this is just consisting of 2 steps: doing a verify and then just echoing the pass to do that. So this would be something that like a release manager or whoever would be determining to let it out into the public would run. Okay, so then here I'm saying for the final layout, a lot of it's kind of the same whenever you see it, at least in terms of looks. It's just basically doing the in-toto verify command of an internal layout to do that. But it's going to chain all the attestations together, and this would allow, it should produce customer confidence that if they're able to run with that it verified that they got what you said they got, and all of the other operations that it occurred as you would have wanted to run, and all the artifacts. So all of the build objects that it had been the same, and nothing was modified throughout the entire life cycle of it. Okay, so before I get into the demo, does anyone have any questions of in-toto or attestations or anything, or no? Okay. All right. So I hope you don't mind seeing seeing some command line output. So here I have some Python files. There's a couple keys here. So this is how my private key is. It's just called owner. I have owner.pub. This is the public key for it. I have three different layouts. I actually left my layouts in here, but that. Let me make sure that yeah. We'll just run it. All right. All right. Okay, it's sourced. So I'm going to copy it from what? Gotta love Mac and live demos. All right. So here, okay, let me try this one more time. There we go. All right, so I created 3 layouts here: build layout, internal layout, and release layout from the 3 different Python files here. Sorry for my laziness of calling it create layout, internal layout, and release layout. Create layout was the first one that I was using for build, so I'll show you I'll show you how it's done here. So you can see I'm using the user from it's doing relative path for the public key for GitLab in this instance. That's who I'm using for this. The owner is different. It's the private key. One very important part, whenever it comes to your keys, it's very important to keep your private key safe. So this is not, I'm not going to tell you how to handle that. That would be up to you. I'm just using it like this as a very simple example. I generated these keys on my own using I think OpenSSL to generate that. This is a lot of the same cargo build. I have a very simple Rust program that I wrote that just prints a line like, hey, this is a Rust binary. I do package it up down here, so I'm tarring up the file, creating it called package.tar, and this is the actual binary of it. So let's go into the actual build. Let me get my command that I need to run. So, okay. Here, I wish it would stop doing that. Here, I'm going to run these 3 commands. This is what this is going to do is just clean up, because I probably didn't have cleaned it up. It's going to build it. It's going to run a lint check, which is cargo clippy, and then package up the files. And you can see that I probably already have a problem with Rust, because they always seem to update and cause me grief. Let's make sure that this does something. Okay, simple text. That's what the program's meant to do. So just run simple text. Okay. So now I ran those 3 commands. They were wrapped in the in-toto run. So let's take a look at one of these actual attestations. So we'll look at the first one here, the building. So here you can see that it generated it. It puts in a signature, but down here we have as part of the byproducts here, cargo is outputting the standard error. And it gives you different things like, hey, it gave you a path to where my cargo config is. That could be, I'm sure someone that would be nefarious may want to know that information to be able to maybe inject something in there at some point. So you wouldn't want to have something like that go out. Here's the return value. If it would have failed the command, the attestation still be created. And the version that I'm on, the in-toto verify 3.0, it does not do validation of the byproducts for the return code value. There is an ITE for that. I think it's ITE 11. But it can do other things here. You can see like environment gives the command that was run. If I would put in some debug flags to cargo build, I don't know if you're familiar with like GCC, maybe you put in like change it from like a debug flag to something else that could deviate from this, and it will give you a warning about it, but it'll at least tell you that there's a problem with it. And here you can see some of the checksums that are created for all these files that are there. And it includes the path of it too. So that's another thing. That's why you wouldn't necessarily want to have something like this being published out to consumers that would be using it. Similarly for the other ones. If you want to see that, I can go into that too. All right. Let me look at where I'm at in my thing. So I called it stage 1. Okay, so this is where things are going to deviate a little bit from that directory, and it's important to change it into a clean workspace, so that way it's not going to be capturing things like your source code in the paths and stamping them with its SHA string prior to going out. And you can include that into your in-toto layout to say, don't allow those types of files to be there. All right. So there, I just made a directory, called it stage 1, copied in the files, the ones that I felt were necessary. I'm grabbing the layouts, the attestations, the public keys, and the package. And I actually extracted it here too. Let me see. So here, so now I'm going to run these 2 commands. So here, like I had said, so this is just doing the verification of the build. So in between here, I would typically do some kind of testing or having automated tests that are included with this. I'm kind of setting the stage for manual testing at this point. But that would be possible. All right. Let's see where. All right. So here I'm calling this stage 2. So this is like a pre-release stage. So now in this stage, what I'm doing is I'm copying the public keys from the previous stage, the specific attestations that I cared about here, the verify, the testing, and the package. So it's important to keep the package, the tarball that I'm using here, within all 3 of these, because it's every time that I'm doing the verify, it's verifying that this matches the one that was in the previous attestation and previous layout that was verified. Okay, so you can see I have, let me see, kind of lost track of where I'm at. Stage 2, okay. So here I'm going to go into the final one. So in this case, I told it to do verbose, so you can kind of see a little bit of like what all it's doing. It's verifying that these files are allowed, and verify all the matches. So the last one that would go is this one here, I think. So you can see here, whenever we're running this as a last step prior to going out, there's no byproducts that are being produced here. So we're not having to worry about leaking any kind of command line standard error out, standard out, any kind of pathing with that. The only thing that would be shown would be the files that are in the directory that I had previously used. That's why you're seeing this internal layout, the owner pub package tar, but that's it. So yeah. So that's a lot of what I wanted to show for that. If you want, I'll show you some of the keys so you can get a look. They're just, I used PEM to create these. But it's not a whole lot of work in there. How am I on time? Am I pretty good? So does anyone have any questions about any of this? Yeah.
So I've seen so this is the metadata in that binary. Is that back to
so the data that you're seeing, so like it's generating it. I think it's doing it through like the size, the timestamp of it to generate it. If you want, I don't mind playing around with this environment. We can mess around with the files if you want. I can just echo some stuff to it. So let me go into like stage 2. Let me just echo into the package. Okay. So now package.tar is different, right? Let me get my in-toto run command. So you can see the run command has a lot of stuff to it. Stage 2 in-toto run. All right. Let's look at. Okay, that I don't think was supposed to happen. All right, let's take a look at this one. Okay, so we do see that the checksum is different because it's not included here. It's different from this one. So I thought I had it set so that, well, so this is why it's like it's good to play around with things and try it out. I thought that it was set to do the link so we'd have the chain of attestations. If you mess around with it anywhere in between, that it would no longer work. Oh, because I did a verify of the layout of internal layout, and at that time it was okay. So if I went to release and I copy stage 2, let me just scroll up to, don't want to create a new one. And it says everything passed. Yeah. So I obviously did something wrong. You're supposed to be able to disallow it. I know if I do work with just the one attestation that they show for building, it was working there. I was trying to go a little bit outside of the box to create it as a series of chained attestations. So it's basically what you're giving to the customer should only allow no output being provided to them to like not leak corporate secrets, basically. Was it a feeble attempt at it? Yeah. Mm-hmm.
What type of encryption tool are you using to generate your key or what type of public-private keys?
So okay, the private and public keys, they weren't generated by in-toto. I think I used OpenSSL, and it was just like the PEM algorithm to do that. Yeah. Anyone else have any other questions? I'm happy to try to break things as well, because like this is good to try things out and learn that, you know, I'm wrong. Yeah.
Want to verify that your artifact that God is the one you created, not some other bad act, right?
Mm-hmm.
Give me maybe a sense of how it's perfect if you just if only you use your own artifacts internally. Like you have a dev team, you have a QA team, you have a ops team. Can you see a use case for that kind of thing, like verifying internally, or is it mostly for kind of external?
So it's meant to be, I think, more for the end customer, but doing it within the same organization. If you have it as part of the verify that you're pushing to an Artifactory. I know Artifactory has things like they have their own checksum. Oh man, I can't speak. They have that to verify what you're pushing, like the artifact to, and it does its own verification that it all matches. So if you're verifying that your build came that way and then you're pushing to it, it could even be a public facing Artifactory in that case, like a lot of third party, like a what is it, PyPy or whatever. If it's something like that, then, but yeah, internal teams could use it as well. So if you're pushing to your own internal Artifactory and using that to download to verify. I know that whenever I worked at a previous company, we did things like just like catting out a string from the build to be able to determine what I'm actually testing for like a release, and it was like it had to match this string or whatever. Well, this does a little bit more verification of that, like it verifies all the build components of it as opposed to it. So we know at least works with the with the single layout doing the verify of the build. So I can show you that. I can screw that one up, and we can definitely see it. So like I already have things built here. So let me okay, and then let me check my commands. So now I had previously built, the layouts are still in here from this step. So here I'm going to just create a new package here. So now all I did was just create the new package.tar. So if I go into stage 1 and I copy, it's a lot easier having the commands all copied like this. So let me do this, and we'll execute this verify so you can kind of see it run. This is kind of what you would see, right? What it does is it kind of works its way backwards through the layout to tell you what rules it hit, what rules had functioned, and like what the difference is. So here it's saying at the end, hey, these two files don't match anything after we're done. That's done because of the disallow star. So that's why it's important to wrap it with that, because if you don't have it, then it'll pretty much allow anything in that case. But yeah, this can prevent things from like if someone were to mess around with the code after it's been built and trying to like push to a server in that case. Does anyone have any other questions? We have how much time? We have 10. Okay. Well, I can. So everyone everyone familiar with the checksums? With doing that, do you typically download, whenever you download some kind of file, do you verify the checksum of what you're using all the time? Okay. So that's where a case like this, at least in stage one, something like this would definitely help out with that. I think I copied too many public keys because I don't think we would need the actual, I think it's the owner public key. We just need the GitLab in this case. Whoop, let me go into one of the attestations here. All right. Okay. So yeah, you can see, like I mentioned before, with the byproducts and the return values not being verified. One of the things that I know that I had done previously was to use some of the inspection, which I had said before. It's not, I don't have that included in the layout because it's just blank. Down here, inspect. I know that a lot of times things take time to run. You have commands, a build can take a while to build. I know some systems, it can take like upwards of 40 minutes. For whatever reason, in-toto defaults to 10 seconds. I found that to be not great. Inspect was a way for me to work around the byproduct not being validated. So if I were to generate an SBOM and I wanted to do a gripe scan and say I don't want anything that's like in there, if there's any CVEs or anything like that, I want it to fail. If you put that in as a step at this point without ITE 11 being done, it will just pass. If you put it into the inspect saying, hey, I do the gripe scan at this stage, it will enforce the failure. One other thing that I could try, and I should be able to show is, so I had wrote here to do a build command. Let me show this. All right, so if we generate the build, and I don't know if I can just give it another option. Okay, let's do that, -- help. So it generates some additional output, but we have the build building FE. Yeah, sorry. Okay, so here we have this. If I were to take this building to stage one and execute that, I want to see if I can. Oh, it's still going to mess up with the. Hang on one second. Let me do this. Let me just start the build over again because this is going to mess up everything up. All right, let's do this. Okay, generating the tar. Now let me go in here and put in. Okay, so I just added in an additional command there at that point. Stage one. All right. I'm copying my attestations to my stage one. Gonna look at my command here and all right. This is much harder to read with large font. was hoping just to show it. Oh yeah, right here. This is what I wanted to show. It's right at the top. So if you were to execute the command with additional flags that you may want to use, it'll show up there like that, but it's a warning. It's not an error. If we look at the building, we can even see here, this is kind of showing that the return value 1, it fails. That would be considered a failure in DevOps, but to in-toto right now, it's considered just a warning. And you can see like it captures all that in the command. I think I'm at like 5 minutes. So if there's no other questions, I mean, I don't really have anything else.